lesson 28 from our unit 7. Uh, so just if you remember from lesson 27, we went through all the different characteristics, the different portions of the graph, so domain, range, and behavior, asymptotes, increasing, decreasing interval, extrema, xy intercept, and so on. And then we went through and we kind of did a building and trial graph for 6 different graphs. Well, today in this lesson we're going to focus in on 3 different graphs and then learn how to graph absolute value inequalities and equations by hand. All right, so let's get into it. All right, so the first one of the 3 graphs that we're focusing on this lesson is the linear graph. So this is the linear graph. It's called a linear function. And the equation is f of x or x. Remember, f of x is just a different way to write y. F of x equals x. So with that being said, here's our line, okay? And you would have studied this in Algebra 1, like y equals mx plus b. So the difference here is we didn't have like a value for b for the y-intercept. So we're going to plug some numbers in here. So -2, remember if f of x equals x, then that means these two numbers are the same. So you'll see that shows up as a point on our line. And then I just want to pick 3 other points. So how about 0, 0, 3, 3, and I'll go with 6, 6. You really could do anything, any of 4 points, as long as they're on this line. Okay, so now let's fill in our characteristics. So the vertex center point, well, for all of these, it's going to be at 0, 0 because there's no transformation. So it's just at that point right there. Domain. So remember, that's the x values, okay? So our x values, the graph goes left forever. So it goes to the left forever, indicated by that arrow, and it goes to the right forever, indicated by that arrow. So in other words, the domain could be anything. So we're going to write all real numbers. Now that's one of the 2 options for how to write this type of answer. And in a second for the range, we'll show the other one. So the range, or the y values, well, just like it went left and right, it also goes down and up with arrows, so it goes forever. So this time, we'll just write it in a different way. So we'll write negative infinity, comma, infinity. And there are parentheses there because we can't ever actually get to those 2 values. So that's just a different way of writing this same type of answer. All right, next the xy intercept. So in this case, it actually becomes pretty straightforward because it's just this point, 0, 0, right? So 0, 0 is both an x and a y intercept. And in this case, that is the same value for both of these 2 points. So the x-intercept is 0, 0, and the y-intercept is 0, 0. Okay, so the decrease in interval. So decrease and increase interval, remember we read the graph from left to right, and we ask ourselves, when is it going up? What are the values of x? And when the graph is going down, what are the values of x? So if we start from the far left end of the graph, in other words, technically we're starting at negative infinity. Well, what happens here? We go to the right, to the right, to the right. Well, the whole time as we go from the left to the right, we go up. So if you read this from left to right, you always go up. So in other words, the decrease in interval is, well, there isn't one, so we write D and E for does not exist. And then the increase interval is going to be all real numbers, or negative infinity to infinity. All right, awesome. Okay, so now, what about our extrema? So remember that extrema is where we change directions. Was this graph ever change directions? No, so it does not exist. Asymptote, so those lines where we curve that show the shape, the dotted lines, well, I don't see any of those, so it does not exist. Okay, and behavior. So as x approaches negative infinity, so if we go on this graph left forever, what happens? We go down. So y would have to approach negative infinity. Okay? And then as we go to positive infinity, so if we go to the right on the graph forever, well, it keeps going up. So y would approach positive infinity. Okay? So those are those main characteristics for the parent function of the linear graph. Let's look at the quadratic. Okay, so the quadratic is f of x, or again, meaning y, equals x squared. So again, let's pick some points. How about -2? Well, -2 squared is -2 times -2, which is 4. And then it's 0 squared. Well, 0 times 0 is 0. How about 3? Well, 3 times 3 is 9. So you can see all those. Let's pick another one here. How about 1? Right? 1 squared, 1 times 1 is 1. So you can see all of those points are on that curve. Again, the vertex center point for this is 0, 0, because we're not doing any transformations of these functions to begin with. All right, so next, the domain. So what happens for the x values? So this goes to the left forever, and this goes to the right forever. So right forever, left forever. So again, it's all real numbers. Or again, we could put the negative infinity to positive infinity. Okay, for the range, so what are the y values? Well, the arrows do go up forever, so it goes up to infinity, but there's nothing going down beyond 0. So 0 is the lowest point. Okay, now it could be 0, so that's why we have this 0, up to infinity. So to show that it could be 0, we're going to put a bracket here. So bracket 0, comma, infinity with a parenthesis. All right, x and y intercepts. Well, that's the x, y intercept. It's still 0, 0. So 0, 0, oops. 0, 0. Okay, decreasing and increasing intervals. Well, as we read this from left to right, we go down and then we go up. So remember, if we start all the way on the left, we're at negative infinity. So then for x, we go down until we get to here. So then that's where x is at 0. So we went down from negative infinity to 0. So that's the decreasing interval. So we're going to go parenthesis, negative infinity to 0. And then we go up. So from 0, we go up forever. So we go as we go to the right, we're going to continue to go up forever. So it's going to go up from 0 to infinity. Okay? All right, awesome. All right, extrema. So any point where the graph changes direction. So does this graph change directions? Sure it does. Where does it change directions? Right there. Now, is that a low point, or what we call a minimum, or a high point, what we call a maximum? Well, it's the lowest point, so we're going to say it's a minimum at 0, 0. All right, asymptotes, are there any of those dotted lines it curves towards? No. End behavior. So if we go left forever, we go up. So this should go to infinity. If we go to the right forever, we go up. So it goes to infinity. Okay? So again, left, up, right, up. Either way, we go up forever. So we'll go to infinity both ways. Now here's the thing. As we go to this next graph, notice absolute value. Let's go back to the quadratic. Back to the absolute value. So other than the lines, the way they're curved versus straight, everything else is the same. So let's just fill in this point. Remember, the absolute value means the distance from 0. So the absolute value of -3 is 3. Absolute value 0 is 0. Absolute value of 3 is 3. And then one more. How about absolute value 6 is 6? There you go. So literally these answers are going to be the same answers as what we just had for the quadratic, because that shape of that graph in terms of the way the lines are curved do not change any of these answers. Okay, so the parent function answers here are identical. Okay, so again, it decreased. Where did it decrease, right? Well, starting left forever, it goes down till 0, and then it goes up from 0 till forever. So again, the decrease would be from negative infinity to 0, oops, and then it would increase from 0 to forever. So there you go. All right, and behavior, well, if I go from here, if I go to the right, I go up. If I go to the left, I also go up. So either way, we go to infinity. The asymptotes, well, I don't see any. They don't exist here. Extrema, is there a point where it changes directions? Sure, right there. So we have a minimum at 0, 0. All right, so there we go. All right, one last thing to look at here is how we graph an absolute value inequality. So I want to take this, which is the absolute value, or sorry, y is greater than 2 times the absolute value of x minus 4 plus 1. So when we're graphing these, it's going to look like this. This is the general shape of the graph, and the first thing we're going to have to find is this point called the vertex. So in this case, how do we find the vertex, the point of the v, like we said? So in any form, y equals absolute value of k minus h plus x, the vertex is at hk. So what does that mean? It's the opposite of this sign, because see how this is a minus h, and then this is just h, and then it's just whatever this number is. So here we see this is a 1 out here, so that's why this is a 1. We see this is a minus 4, well that's why this is just a 4. So the vertex is at 4, comma 1. All right, how do we find the slope? We multiply the coefficient of the absolute value by the coefficient of x. So we multiply out here 2 times, well there's nothing in here, so it's implied to be a 1. 2 times 1 is 2. That is the slope. So remember, it's got a form of v, so we do it both ways. We go basically up to right 1 and up to left 1. Okay, and then does it open up or down? Well, if it's positive, the graph opens up. If it's a negative, the graph opens down. This is a positive slope, so it opens up. Then we want to know what kind of line are we going to draw, a dotted or a solid line. So for a dotted line, you're going to have no or equal to sign, okay? And that means the points on the line are not solutions. If it has an or equal to, that makes it a solid line, and that means the points on the line are solutions, okay? All right, then we got to figure out where do we shade. So in terms of shading, what we're going to look for is if it's a less than, we're going to shade below the graph. And if it's a greater than, we're going to shade above the graph. Okay? All right, so now let's show it one time. So here we go. So we're going to take this and try and graph it on here. All right, so let's do it. So the very first thing to look for is the vertex. So again, it's the opposite of this sign. So that's a plus 2, so my vertex is at negative 2, comma, and then it's whatever this is, which is 3. So negative 2, comma 3. All right, next we look for what the slope is. So I don't see any numbers out here, so the slope's implied to be a 1. All right, next we're looking for what happens in terms of does it open up or down. Well, the slope is positive, so since it's positive, it's going to open up. Then we're going to look for what happens in terms of a solid or dotted line. So what kind of line do we have? Well, there's an or equal to here, so it's going to be a solid line. And then it's a less than. So since it's a less than, where are we going to shade? We're going to shade below the line. So let's show it. Let's graph the point negative 2, 3. So left 2, up 3. Okay, and now we need a slope of 1. So I'm going to go up 1, right 1, up 1, right 1, up 1, right. Yeah, I could do a few of them. Up 1, left 1, up 1, left 1, up 1, left 1. And then I need a solid line. I'm going to throw arrows on it. And then we're going to shade below, meaning we're going to shade everything down here. And again, we're just showing that basically all of this, any point over here is a correct solution to this inequality. Okay, absolute value inequality. You don't have to feel like you shade literally every single thing. All right, I hope this helps. Make sure then you do screens 9 through 14. 9's a vocabulary checkup. 10, 11, 12 are making sure you understand the different characteristics from the parent functions. And then 13, you get to apply your skills with a different type of graph, so same thing. And then 14 is basically, can you do what we did from screen 7? All right, hope this helps.